Hi everyone. Today we are going to walk through the process of constraining an eigenvector for MSC Nastran Optimization. I'm going to describe what our model is for today. I'm going to describe what the optimization problem statement is. And then I'm going to walk you through the process of actually constraining the eigenvector for optimization. So to start off with, let's describe the model. Here I have this rod. It's pinned at 2 points. Here in red, it might be worth zooming in actually. Here in red is the first mode shape for the initial design. This mode is in the YX plane of this model. We're going to impose a constraint that says the maximum relative displacement, which is approximately negative 4.5, the relative displacement of the first mode shape should be no more than -3. So here in blue is the final design after the optimization. So let's go ahead and jump over to our description of the model. We have a rod that's 12 inches in length. Our beginning cross-section has a radius of 0.25 inches. Again, we are pinning it at this point that you see me highlight with the laser, and we are also pinning it at this point that you see me circle here. And here this image summarizes what I just said. Our optimization problem statement is as follows. Our objective is to minimize the weight of this rod. The radius of the cross section will be allowed to vary. We're going to impose a relative displacement constraint on the eigenvector that says it is not to go beyond -3 or 3. Now let's go ahead and do this right now. Here in Patron, I have this rod already loaded with my results. So let's go ahead and take a look at the first mode shape. Here you can see that the first mode shape is about 4.38. And this is a relative displacement. It has no units. So again, our maximum relative displacement for mode 1 is 4.38. We're going to impose a constraint at this tip, which is node 13, that says the relative displacement at node 13 for mode 1 is to be within -3 or +3. So let's go ahead and walk you through the process. I already constructed most of the design model, so my objective, my design variable is already included in this input file. I just have to create my constraint. So in the web app, click on constraints and change the analysis type to normal modes. And let's go ahead and describe why that is. First, let me just leave it as statics and click on displacement. Let me then switch this to normal modes and type and click on displacement to create a new constraint. Here, R1, or the first row, is a displacement constraint for statics. And you'll notice that the ATTB field is highlighted out, indicating it's not necessary for this constraint. But the second constraint that was created based on a solution 103 or normal modes analysis, the ATTB field is now open for you to type it in. So now let's go ahead and fill this field in. So we are constraining the y, or the second component of displacement, for node 13, and we're saying that the bound can be no more than -3 or +3. Make sure to type in the decimal point here and here. But right now, without the ATTB field, it won't know what mode you want to constrain. This is where we can specify we want to constrain mode 1. So we type in mode 1 here. And now we can delete this previous row 1. So we're just left with the constraint for mode 1. And now that completes the creation of this constraint. Let's go ahead and copy these statements to our design model and actually perform our optimization. And let me go ahead and start Nastran and point to this design model. And let me go ahead and make one comment. The modes are listed in increasing natural frequencies. So mode 1 is 29 hertz, mode 2 is 47 hertz, etc., etc. it is possible that mode 1, which has this physical shape, could potentially have a higher frequency than 47 hertz. This would cause the mode number to switch. This might be an issue because right now we've said track mode 1 and constrain that mode. If it then switches to mode 2, it would eventually optimize the incorrect mode shape. There is a statement called mode track. Actually, did I include that in here? So mode track is in my case control command. Mode track is here too. These two statements allow you to track your modes. So in the event that mode 1 were to jump and be between modes 2 and 3, this will shuffle the ordering of the modes. Mode track allows you to make sure you're still tracking the same mode shape. Now let's go ahead and open our optimization results. And I just want to make sure that the message a run terminated due to hard convergence at an optimum is there. It's indicating that it's a successful optimization. Let's go ahead and view our results now. So this is what we expect. Again, our initial mode shape had a maximum relative displacement of negative 4.38. We impose a constraint at the very tip, node 13, that said the relative displacement is not to go beyond negative 3. And so here in blue is the new mode shape for mode 1. We find that the radius went from 0.25 inches to 0.36 inches. And the way you can tell is if you look at the design variable history, we started at 0.25 inches and then we ended at design cycle 5 at 0.36 inches. Here our mass started at 0.2379 and we ended at 0.5. And these are the same values we found in our PowerPoint. Let's go ahead and view the results in Patran. The result file that was created during the optimization process includes both the results of the original design. So here this will give us a 4.38 or negative 4.38. It gives us the initial results, and if you scroll down, we have another set of results. And this, you'll see it says, or rather, if it says D0, so D as in Delaware, if it says D0, that means it's design cycle 0 or the initial analysis. If you scroll down, you'll eventually find something that says D5. The number might be different. It might be D10 depending on what design cycle the optimization ended. Here, D5, mode 1. This is the mode shape for my final design cycle. You see the mode shape. It still has the same mode shape, but now the relative displacement is now 3. And so that in essence is how to constrain an eigenvector for optimization. If you have questions on how to do this for MSC Nastran, if you want access to the web app that let me constrain this model, feel free to email me at this email address at the bottom right hand corner, and I'd be more than glad to have a discussion with you. With that, that concludes the end of the video, and thank you for watching.